Hi, good morning, everyone. This is Nicole Testa Boston. I'm the Deputy Director here at Fiatech, and I want to thank all of you for joining us today for our Fiatech Technology Tuesday webinar. We're going to be hearing from one of Fiatech's members, ARX, in a few moments, talking about engineering new levels of efficiency and collaboration with digital signatures. This is also an ongoing project that we have in Fiatech, so we encourage you to participate if you like what you hear and want some more information. Before we get started and I introduce our speaker, though, I wanted to do a little housekeeping. First, let you know that we are recording today's session, both the slides and the audio. We will post that on the fiatech.org website later today under our events and webinar archive section. I also wanted to point out that you are all on a muted default setting, which means you do not have audio controls, but we do encourage participation through the questions tab on that toolbar. So you can use that at any time during the presentation, type in questions or points that you'd like further clarification on. Those questions will go directly to me, and I will moderate a Q&A discussion with John at the end of his webinar. If we run out of time and we don't get to your question, John will follow up with you following this webinar. So with that, I want to go ahead and introduce John Marchioni. He has over 25 years of experience in information streamlining and process automation. His current assignment is with ARX, the digital signature company, having previously worked for solutions vendor Microsoft and Burroughs Unisys. John was appointed visiting scholar for informatics at UC Berkeley, where his research focused on friction reduction in information processing. He is a member of the Security Council of the Gerson Lerman Group. He has been a panel speaker for NSF at workshops on grid computing and the cyber infrastructure, and is a member of the advisory board of UCLA's Center for Embedded Network Sensing. He also served as Director of Technology Programs and Advisor at Gordon and Betty Moore Foundation. I want to thank you, John, for joining us today, and turn it over to you to go ahead and get started.
Okay. Thanks, Nicole, and good morning or good afternoon, everyone, depending on your time zone. I'm going to give you an overview today on digital signatures and why they're important for business, what kind of problems they solve in business streamlining. We'll talk a little bit about regulatory compliance and what exactly are digital signatures. We'll spend a little time on a primer, show you how the mechanism works, and then finally we'll talk about a deployment example. But for context, what I'd like to do is start off with a couple of demos, just to kind of put, for context, show you what digital signatures are, what they look like to an end user. Here I have a Word document open in Microsoft Word, and it's got a couple sections in it. This is a vacation request form. I'm asking for some vacation. So I would, if I filled this form correctly, I would then just want to sign on it. So I would come down here and right mouse click and sign. I can choose the appearance, in this case, of my graphic signature. This is not a digital signature. This is just a visible indication of who signed the document. Then I would click a sign button. The program would issue an identity challenge to me. It would tell me it would ask me to identify who I am by username and password in this case. And if I answer the identity challenge correctly, my standard digital signature is applied to this document. And then if I want to inspect the details of this signature, I simply right mouse click in Microsoft Office or Word and say, show me the details. And Microsoft Word will tell me the signature is okay, the time I signed it, who signed it, and also proof of my identity here by my certificate, which is now embedded into this document. Okay, so I've digitally signed this, and if I'm pretending this is a mini workflow, I'm going to pass the document to my manager for approval. She says, okay, have a nice trip on your vacation. Okay, And then I'm going to pretend I'm the manager, so I'll also right mouse click and sign. I'll just pick a different ink color here. And now I've signed this document as well, or my manager has. You notice, though, that the document has changed. I've added some text here and signed it, but the signature up here is still valid. And if I right mouse click on this signature, say, show me the signed area, I can see the scope of this first signature only applies to this part of the document. And since nothing in this part of the document changed, this signature is still valid. Okay. However, if I do change something in this section, say I change it from 18 to 19 vacation days, and I validate the signature, that signature is now invalid because somebody's tampered with the document. And the same for this signature, because the scope of this signature is over the entire document. So this is the basic look and feel of a digital signature, and demonstrates some of the basic values, which include proof of signer identity by certificate, but also proof of integrity, meaning that no tampering with a digital signature will ever go undetected. Okay, so that's a simple Word demo. Let me show you what this looks like in PDF. If I take PDF drawing here, I simply right mouse click and say sign with cosign. I will get a preview of this PDF. I can go from page to page, go to the page where I want to place my signature. Click this sign button, take my mouse, and draw a box where I want my signature to appear on the PDF. Again, I can choose the appearance of my signature. Click sign, answer the identity challenge, and now I've digitally signed this PDF. I'll save it back, and then anybody can inspect this document with a free Adobe Reader. I'm opening it now with a free Adobe Reader. The Adobe Reader has functions in it similar to Office. If I right mouse click here and say show me the signature properties, Adobe Reader will recognize and verify this digital signature and show me the details, who signed it, okay, by certificate, when they signed it, why they signed it, and also Adobe Reader confirms the document has not been modified since the signature was applied. Okay, and in this case, this is a multimedia PDF. The digital signature, of course, the act of signing the PDF still retains all the original properties of the PDF. Okay, so that's one way to sign a PDF. Another one is if I open this PDF, I have set in signature placeholder fields in this PDF. So I just right mouse click on that. I right mouse click, I say sign with cosign, and I double click. I can choose all variations of visible signature, including one that is my professional seal if I wish, and I can sign. So the graphic image in this case is not simply an image of my handwritten signature, but it's also my digitized professional seal. And then same as before, if anyone wants to inspect this document, all they need to do is open it in the free Adobe Reader, right mouse click, look at the properties of the standard digital signature that are now embedded in this document. Proof of identity, intent, proof of integrity, proof of date and time are all now carried within this PDF, but in this case using a different graphical representation, in this case that of my digitized professional seal. Okay, so that gives you an idea of what you can do from a user standpoint with digital signatures. Now let's go in and explore some of the things on the agenda here. So the main business driver, as we see it, is that paper is a problem. Paper is too expensive. I'm not going to read these quotes here, but I'll read one. The AEC industry spends an estimated $500 million or more each year moving plans from one discipline to another via such couriers such as FedEx. Okay, so the issue is when you're producing that paper for a signature, for approval, for any reason that requires a signature, you're really slowing down your business and at the same time increasing your overhead costs. Okay, so paper is a problem. Paper is just too expensive. This is from a survey done by AIM in 2010, which found that in 56% of all the organizations that they interviewed, more than half of the documents printed were printed for no other reason than just to get a signature on the document. So imagine if you start signing digitally today or tomorrow. As soon as you do, the savings associated with paper-based burdens or paper-based costs are going to reduce by at least half. Okay, because again, half of the paper printed is printed for no other reason than to get a signature. The other thing that they found is that if you can sign digitally, you're going to accelerate the velocity at which your business process works. So any process that's signature dependent is automatically going to accelerate or speed up or streamline if you can sign digitally. Okay, and then the other interesting thing that the AIM survey found is that the engineering and construction market is among the most signature-intensive markets around. As far as if you compare it to other vertical industries, it really comes in at the top as the vertical that requires the highest volume of signatures. So one could conclude that savings from digital signing is got the best potential for savings in the architecture, engineering, and construction market. Okay. So why digital signatures? Well, you want to automate signature-dependent processes. These are processes whereby you need to express ownership or source or custody or acceptance or approval or an agreement. Okay, lots of reasons to sign, so therefore lots of signature-dependent processes. Okay, that could be improved. You also need a digital signature when you need to maintain integrity and verification of the document. So you need that integrity check inside your organization, outside your organization, and also in the long-term records archive. You want to be able to pull the record 30 years from now, 50 years from now, and be able to verify who signed it, when they signed it, why they signed it. Okay. And then also in regulated markets and those organizations that have audit requirements or concerns with good governance, a digital signature allows you to ease the burdens of audit regulation compliance and really allows you to automate under a good business practice for maintaining control and maintaining integrity of those documents. Okay, maintaining control of signature privilege, for example. Okay, how do digital signatures benefit AEC firms? We see three primary areas: collaboration and quality, faster project delivery, and cost savings, of course. So here's a quote from Black & Veatch. They look toward digital signatures for the main purpose of enabling remote engineers to sign drawings and other documents and keep the workflow going. So the point is, their engineers can be out in the field, they can be in dispersed geographic locations, but can still be part of the workflow, the electronic workflow, and still apply their signatures to those electronic drawings, reports, estimates, and so on, and keep that workflow moving, and also allow access for each workflow or each project to the appropriate engineer, the appropriate specialist, can be included without pushing paper from place to place and without having to have everybody located in the same office. Okay? So this results in more efficient collaboration, enhanced design integrity, not so much for the design, but after the design is done, digital signature maintains the integrity of what is signed, and then also the efficiency of the process. Things happen faster and with less friction. Faster project delivery, okay, along the same lines. In the past, it could take several weeks to turn a document around. This is from Hague Engineering. That's when they were using paper and wet signatures. Today, with digital signatures, their engineers can electronically sign from remote offices as well as remote locations with the internet access, thereby allowing them to turn around documents in less than a day instead of weeks. Okay. So once the project gets going, what they're always faced with is that the clients typically push for a faster delivery time. Digital signatures cut the printing, routing, and the delays involved with handling paper. This results, of course, then in faster response time to the customer, fewer late projects, and a greater agility to address client change orders on the fly. Then finally, Braun Intertech. They're saving at least 2,000 to 3,000 hours a year in labor alone. Again, just by cutting the overhead associated with paper, they're cutting down on staff time, printing costs, scanning, routing, archiving, replacing lost documents. Digital signatures significantly reduce paper usage, and of course, not only does this lower cost, there's a noticeable improvement on environmental impact as well. You get rid of, stop using paper, you stop putting carbon, stop doing things that put carbon into the environment. Okay, keep the carbon in the trees. That's the best place for it. Switching gears a little bit, regulatory compliance. Digital signatures are legally enforceable in all U.S. states and territories and in Europe. There's another aspect that we get asked about, and that's professional seals, professional engineer seals. These are different from digital signatures. These are controlled and issued by state-level professional engineering boards, and they control the use of the seal and how it gets applied and who's entitled to have a seal and so on. So there's a distinction here between a digital seal and a digital signature, or I should say a digitized seal and a digital signature. PE board regulations, from what we have learned in talking to various PE boards, the majority of PE boards, at least 40, encourage the use of electronic content and digital signatures on that content. Several recognize digital signatures as the most reliable and secure option for signing. Some recognize digital signatures as the only acceptable and legally enforceable electronic signature. And PE boards will not endorse however, PE boards will not endorse a specific solution, nor will they criticize a specific technology approach. They want to appear neutral. However, they do recognize the economies one gets from not having to print to sign and from commercial off-the-shelf solutions that are also based on proven standards. So kind of hinting at what the guidelines should be from the PE boards that have looked at the subject. Okay, now I'm going to launch into a digital signature primer. I'm going to explain how the mechanism works. The first thing to notice is that digital signatures are a standard. The U.S. designation for that standard is referred to as NIST FIPS Pub 186. This is the standard that replaces slow, inefficient paper-based signatures for signing electronic documents, drawings, designs, reports, calculations, records, and so on. Okay. So There are other options to digital signatures. There are what's referred to broadly as electronic signatures. That's not the electronic signatures are not the subject of this webinar, but electronic signatures are proprietary. They are unvetted, and typically across the board there's no consistency among vendors that offer electronic signatures. Digital signatures, on the other hand, are standard signatures, and this means that it prevents vendor lock-in. So you can, what this means is you can, if you have a standard signature, you can either move from vendor to vendor later, or more importantly, when you sign that document, you can send it outside your organization, and the person receiving it will be able to inspect and verify that signature. Okay? Digital signatures also provide proven integrity, meaning this is integrity that's undergone peer review, and that it's been proven to maintain the integrity of the document. Likewise, a digital signature ensures immunity to forgery, meaning you cannot lift a digital signature from one document and paste it onto another. It's impossible. These are the primary benefits you get from a digital signature that you could not get from a proprietary electronic signature. Okay. This is how the mechanism works. I'm going to explain it. Just keep in mind that the end user doesn't feel any of this process. And this is what was happening in the background when I showed you those demos, when I signed the Word document or the PDF. This is what was happening. It all happens within a second, and the user doesn't feel it. So the user opens their document. They'll complete it. They'll push a sign button. The first thing that happens is the document is passed through a hash algorithm. This yields a unique digital fingerprint or a unique digital DNA for the document. No two documents will ever have the same hash value. Okay? So if I take a document and I hash it, I'll get a specific hash value. If I take the same document and change just one character, say I change from a lowercase a to an uppercase a, and hash the document again, several bits in the resulting hash are going to flip in value. Something's been tampered with, something's changed. Okay? So the document hash is the integrity check component of the digital signature. The next part of this is every signer has a set of signature credentials made up of a key pair and a certificate. One part of that key pair is a private key. This is a large 1024-bit integer that is unique to the signer. No two signers will ever have the same private key. The basic digital signature then is taking that private key and calculating an encryption function over the hash. So the digital signature has two contributors. It has the document, which is contributing its hash, and the signer, which is contributing their private key. So you could, in terms of biology, think of this as two parents. The document is a parent and the signer is a parent. They're both contributing something unique to them to produce a child that we would refer to as a digital signature. So a digital signature, if you think about it, contains the DNA of the document and the DNA of the signer, and this creates a very strong binding between the signer and the document. Okay? The next part of the process is every signer or user has a digital identity. Okay? This contains the public key that corresponds to their private key and their identity. Think of it as a driver's license with a unique number in it, like a driver's license number, only in this case it's a public key. That digital identity is embedded in the document along with the encrypted hash. It's embedded into the signature block, and that signature block, which holds the binding between signer and document, is embedded in the document at the metadata level. Then any attempt to tamper with the document will invalidate the signature. You saw that as well. When I made the tamper, the signature would no longer verify. The hash of the document that was originally signed was different from the hash that we were viewing at that time. Therefore, the signature did not verify, and you saw a big red X over the signature instead of the green check mark. Okay, so that's the basic mechanism of a digital signature. Nothing that users should worry about. Happens in the background, very secure, and the result is a digitally signed electronic record. So when you sign a document in this manner, you're actually transforming it from a document into a legally enforceable record. It'll have all the evidence inside. This allows for a fully trusted and reliably verifiable record. And you can, because it's a standard, you can verify the signature without any costly, complex, or proprietary software. For example, I verified the signatures in PDF using just the Adobe Reader. And also without requiring access to the system that created it, meaning everything you need to verify the document travels with the document. So you don't need to connect to the originating system. You have a fully atomic and mobile verifiable record once it's been digitally signed. So why are these standards so important? Well, standards are well known, they're peer reviewed and vetted. This is the most important thing to note. Why you would want to buy into a standard solution versus proprietary. The standard solutions have been openly vetted, and in this case, the algorithms are public. Okay, proprietary techniques are simply no longer acceptable. These things were first invented at Stanford, and then a year later, MIT and the Weizmann Institute. And then for the hash standard, this is something that the U.S. government has put in place. But these are also international standards. I'm in the U.S., so I refer to their U.S. designations. Because of the peer review, this today is still the only signature technology that's deemed to be immune to forgery. There's no other signature technology, that, especially anything in the proprietary space, that is immune to forgery. All of them are susceptible to forgery attacks. This is the U.S. designation for the standard, FIPS Pub 186. Because it's standard, it's verifiable anytime, anywhere. Signed documents also have effect outside the system that created them because they can be verified. It's technology that will outlive the vendor or the user because, again, it's a standard, it's open, it's published. And this also prevents vendor lock-in or vendor gridlock, so you're not stuck with a single vendor. It's technology that's endorsed at the federal level, at the state level, by standards and regulatory bodies and the Fortune 500. Okay. It allows for easy verification. You saw in the demos, proof of identity, proof of intent, proof of integrity. Okay. So it's very easy to, if you're in a regulated market or you have audit requirements, to inspect the document for integrity, inspect your record for integrity. Anybody can do it, and they can all see the evidence the same way at the same time. And this type of verification allows for trust with all sorts of stakeholders. Because that signature and evidence is embedded in the document, your internal employees can verify, your external partners, suppliers, clients, even regulators or auditors can inspect the evidence and see it the same way. So this is a very, very good mechanism for making sure that once the document becomes electronic, it not only moves without friction, but maintains its integrity, and everybody can see the integrity or inspect the evidence as it goes from place to place. So the basic value of a digital signature provides reliable integrity of information. Green check mark means it's good. Red X means it's bad. Don't trust it. It provides a known origin of information. This eliminates deniability. Once you sign a document in this manner, it's pretty difficult to say that's not your signature, because it in fact contains some of your digital DNA via your private key. And it contains some of the digital DNA of the document via the hash. And it's a standard, which means it's broadly usable. It supports many applications. And because it's a standard, it will survive in the long-term archive. It's very durable. Okay. These are some of the applications that are digital signature aware that my company's product works with. You can sign out of the box PDF, PDFA documents, Excel spreadsheets, Word documents, InfoPath, Autodesk AutoCAD drawings, Bentley, MicroStation, IBM Lotus Forms, and so on. So a pretty broad application in terms of working with various content authoring applications that are signature aware or that can take advantage of a digital signature. So what is the experience for the user and examiner? Well, once the document's been signed, you'll see a green check mark. This is the view if you're inspecting a PDF document. In the upper left, there's a green check mark, and then you also have a visible signature, which is good. You can drill down if you right mouse click, see the validation notice of that signature. And you can also drill down even further and see proof of signer's identity, proof of signer intention by reason code, proof of document integrity. Here's a deployment example. Again, using the Arix cosign appliance. The way this works is when you install cosign into your network, you point it at your user management system or your subscriber database, however you're managing users. And there's a policy behind that system and an administrator already in place. That policy decides who gets to be a valid user in the domain. When they are made a valid user, the administrator will add them to the directory or the database. Cosign is listening, and if that user is allowed signing privilege, Cosign will automatically generate their signature credentials. Cosign will automatically generate their key pair and issue their certificate. So from that point forward, if they can access the network, they can sign documents. Okay. Likewise, if this policy says that, well, this person broke the rules or this person's leaving the company, that person will be removed from the user directory or database. Cosign is still listening and will immediately delete that person's private key and revoke their certificate. So from that instant forward, that person will not be allowed to make even one more signature. Okay. So this architecture allows a very tight control over signature privilege, but at the same time, it does not require any retrofit of established policy, procedure, or system for user management. It simply plugs in under the system that's already being used to enforce and manage users, and so becomes a slave to the policy and procedure already established by the business. Okay, so this is why it's very economical to deploy this type of under this type of an approach. You don't have to rewrite your policies, procedures, or rules. You don't have to change out your user management system. You just add a digital signature capability underneath. The graphic images of, if you want to use this, the graphic signature image or the seal image, these things can also be uploaded into the appliance on a per user basis. And then every time they sign the document, they'll have a pull down. They can choose from any number of signature appearances that they want to have along with the standard digital signature. Okay. This architecture also allows for signing via desktop applications, via web applications, and via mobile applications. So for today's distributed application or today's distributed workflow or organization, that's what this type of signature solution was made for, to allow you to sign wherever you are, to approve on the move, to have access to the signature service as long as you have access to the network and can be authenticated or answer an identity challenge. The username and password that cosign will reuse, again, is the same username and password established by the organization for each user in that domain. So you don't have to maintain a separate username password scheme just for cosign. So it's the same one that they're credentialed with by the organization. It's the same one that they'll be challenged with when they need to make a signature with cosign. Okay. So what's required for trusted collaboration? Well, we believe it's maintaining the evidence or the proof of signer identity, signer intention, and record integrity, and then maintaining control over the establishing and revoking signature privileges. So you get this integrity, intent, and identity via the digital signature embedded in the document, and you get to maintain the control over the process because cosign, in this case, will follow the governance policy and procedure in the system that you already have for installing or enforcing that policy within your organization. You decide when to provision somebody with a signing privilege. You also decide when to revoke those privileges. It's under your control. Proper support for signature automation. We believe the signature must have a strong binding to the signed information. This is what you get between the hash and the private key. That you can reliably identify the signer. This is what you get from the identity certificate. That anyone at any time can verify the integrity of the document or verify the document itself or the identity of the signer. This is what you get by a standard signature. And then also tampering of signed information should be easily and reliably detectable. This is the state of the art. There is no technology that makes something tamper-proof. Any electronic content can be tampered with. So the key is to make sure that no tampers, whether they're intentional, whether they're accidental, make sure those tampers never go undetected, that the people in the workflow, the stakeholders, always know if there's a tamper, and they'll see that by a big red X indication. And then we also believe that signature privileges are best managed centrally by your current pre-established governing policy and procedures. We believe most organizations know how to do good governance. We don't believe that simply because you're adding a digital signature solution that you should be retrofitting policies, procedures, and systems that have been working well for you for years. But simply adding a digital signature solution underneath that will adhere and follow those enforcement mechanisms and policies is the best way to go about the problem of automating signatures. So there are some recorded demos on our website. You can they're narrated by somebody with a nicer voice than mine. You're welcome to look at those. And that concludes my part of the presentation. So Nicole, I think we can open it up for questions.
Okay, thank you, John. Yes, and for those of you who maybe joined late, there's a questions tab on your toolbar there. You can type those in, and those will go directly to me. And I can forward these on here to John. One question here is, point of clarification, is this accepted by the PEGA Association in Canada or just Alberta? Who in Canada is using this, if you can?
We have a lot of customers in Canada, but for that specific regulatory body, I don't even know who PG is. It Pacific? No, I don't know who PGE is in Canada, so I can't speak to it. But we have deployments all over Canada.
Okay. I encourage that person to follow up with John directly. Some users have indicated that some recipients of digital signatures get confused when a document is e-signed and at the same time it is showing an image of the wet signature. Any experiences and recommendations to avoid that?
If I'm understanding the question, they're saying that, well, I'm not sure I'm understanding the question. They said e-sign, and then there's also a graphic image of the signature. Is that correct?
Right. It sounds
Okay.
like maybe a mixture of electronic and digital.
Yeah, so the graphic image of the signature is an electronic signature. It's a digitized form of the handwritten signature. That is not a digital signature. And e-signing, again, refers to some proprietary way of signing. And people get confused when you do electronic signing because no two vendors do it the same way. If you decide that you want to have consistency, that you want to be standards-based, you should insist on standard digital signatures that are FIPS 186 compliant. There is always consistency. Those signatures are always canonical. They always look the same way. They always behave the same way. But as soon as you say e-signing, you're talking about some proprietary technique that's unique to one and only one vendor. And just because you're adding a graphic image to that document, that adds nothing in terms for security. It also adds very little for letting the user know really what mechanism was used to sign the document.
So maybe not the best practice to be used, and those folks should consider digital signatures. What mobile platforms and applications does the digital signatures work with?
So any smartphone or mobile platform that supports a full-featured web browser.
That's just about all of them today, I think. What is the route to get the certificate issuing authority, in this case ARX, trusted by a public route? Okay, so first of all, ARX is not a certificate issuing authority. We are selling a solution that lets our customers issue and manage certificates for their own domain. Okay, so all of our customers, and we have about 1,100 now, have their own private domain key certification and certificate issuing authorities. They are their own certificate authorities. Okay. And they manage those certificates for their own domains. And this is by far, there are by far more co-signed PKIs, more co-signed CAs. And I should clarify by saying more CAs established with co-signed technology than any other technology on the market. And each of our customers controls the governance and management of their own certification authority. Okay. Now, if those organizations want to also use certificates from a public CA, they can do that. CoSign will consume the certificates of any standard online CA service, and we have probably, I don't know, 25 customers that do that out of the 1,100. We also have customers that subordinate their CA to other CAs, meaning the public CA will sign the root key certificate of the customer certificate authority, and then every certificate that customer issues will chain up to the public root of the superior CA. So a number of ways to do that. The options are there. Most of our customers decide they don't want to use third-party certificates because they don't want to pay the tax to a third-party PKI service. Okay, thanks, John. There are some clarifications, folks writing in that the PEGA is APEGA in Alberta, and apparently that is the Engineer Professional Association, and they're wondering if they recognize this as a validated electronic signature.
I don't see why they wouldn't. It's the same standards that are used across Canada the FIPS 186 standard, it's the same in Canada as it is in the U.S. as it is in Europe. So there should be no question whether a standard digital signature is acceptable by a PEGA or anyone else in Canada. There may be an issue with who is operating the certificate authority. Okay, is who's the customer operating the CA? In other words, who's the customer that installed cosign, or what organization installed it and is operating it? But as far as the technology is concerned within cosign, the type of signature within cosign, there should be no question of its suitability.
Okay, and he also wanted to clarify that his question is based on when the e-signed document is printed. I guess that was around, confusion for folks when they have an electronic signature or an e-signature and then it's printed, so they're seeing the wet signature as well. I guess that's more of a process controls.
Yeah, I mean,
issue around.
Yeah, the whole point of this technology is to stop people from hitting the print button. And once you do hit the print button, you no longer have a digital signature because you no longer have a digital medium. So all you're going to be able to ever print is an image. All right. Now you could, I don't know. Well, let me show you a demo here real quick. Let me pull this up again. 18. All right. So now I have valid signatures on this document, right? You can see this. Now, suppose I'm going to be clever, and I'm going to change this 18 to a 19, because I think I'm going to now print green check marks, right? So watch what happens. I'm going to say File, Print, hit the Print button, and what's going to print are red X's. My printer just went off. I'm going to print some red X's now. So what will happen is, before that document is sent to the printer, the verification of the signature is recalculated. So you're not going to be printing green check marks. You're only going to be printing red X's. Okay?
Great. Folks want to know, just to clarify, is it internationally accepted? Will it hold up in a court of law worldwide? What happens on global projects, John?
Yeah, so digital signatures are legal, have legal force and effect everywhere, okay? As far as what holds up in court, it's a matter of did it meet the level of evidentiary procedure, meaning you can submit anything into court. Some things, if they're not handled very well, aren't going to be admissible. Other things, if they are handled well, are admissible. Now, what am I getting at? You can submit anything into the court you want as evidence. And in the U.S. courts don't care if you sign your documents with a digital signature or a crayon. They don't care. What they care about is, did that evidence meet all the rules of evidentiary procedure? Meaning, did you have a documented process and procedure? Were your users trained to follow that process and procedure? And is the evidence you're submitting a result of following those processes and procedures during your routine business? Okay. If you bring something to court and say, here's something that I want to submit as evidence, but we don't usually do it this way. This is a one-off. This is an oddity. The judge is going to say that's not admissible. Why? Because the courts don't want you generating evidence at the last minute, to tilt things in your favor. So it's never a question of legal risk. It's a question of business risk. In other words, you can submit anything to the court you want. Okay. But your business risk says that a digital signature is going to give everybody a lot more confidence in the evidence or proof than a proprietary electronic signature, or in a number of cases, even a signed piece of paper. Signed paper can be much more easily forged than a digitally signed document. Okay.
Okay. Florida statutes and Florida administrative code require architects and engineers to sign and seal documents and plans submitted for public records, and there are specific provisions within the rules and regulations. Does cosign meet the requirements utilizing relative uniform resource locators required by the state of Florida, and can reports be generated from cosign that lists all the files signed and sealed? So I guess grouping them together.
Yeah, so cosign does not provide URLs or URIs. That's a document management issue. However, the cosign log does record the date and time, the identity of every signer, and the hash of every document signed. So within the cosign log, for every signature made, you have the date and time, identity of the signatory, and the hash of the document recorded in the log.
And can you put multiple files together and sign them?
Sure, yeah.
How can a document digitally signed by an external supplier be validated?
Just like I showed you here. So cosign doesn't know a signer is internal or external, and neither does the digital signature. Standard signature is atomic and mobile. So if it's digitally signed with a standard digital signature, you have all the evidence you need right in the document. So yeah, so this is. I could send you this document and you'd be able to verify it. I mean, and see this evidence. So show signature properties, see my certificate, see the date and time, reason code if I used one. Document has not been modified. All I'm using here is the free Adobe Reader and the PDF, the signed PDF. That's it. I'm verifying it.
Well, that kind of, I guess, I think is somewhat around this next question. What happens if the supporting vendor goes out of business? But, you know, I think the issue here is how much does this rely on and the legacy data on the system at the time?
It doesn't. I mean, not at all. In other words, this document that I just signed with cosign, you can decommission cosign and ARX could go out of business today, right now. This will be a durable record that you can always verify tomorrow and 100 years from now if you want, because it's an open standard embedded in the document. So once the document is signed digitally with a standard digital signature, you don't need to connect to the system that created it ever again, nor do you have to have the vendor around to verify the signature.
Okay, I have a few questions around cost, not going into the details of what it costs, but can you explain how it's determined? Is it based on number of signatures, number of users, just one price for the system? How do you calculate what you need to move forward with it?
Yeah, so there's a fixed cost for the base system because it involves an appliance, and then from there it's per user license or per signer license, and it's unlimited signatures on unlimited applications. So these are one-time fees. It's enterprise pricing. So you buy the appliance and you buy licenses for, I don't know how many users you need, and you get replacement treatment. So for example, if you buy 100 signer licenses, 10 people leave your organization, you can reuse those 10. You don't owe us another dime. It's enterprise style of licensing. But if you have different needs, different pricing structure fits your business better, we can always talk about it. So.
Okay, great. And I think this might be the last question. How might you handle adding electronic initials to drawings by technicians or checkers as required per their standard company practice, but at the same time minimize the number of individuals having to acquire digital certificates, essentially saving subscription costs? Managing staff mobilizations and demobilizations could become an issue.
Yeah, let me show you a quick demo here. So you go up here and you pull down this, and you say sign an electronic uncertified signature, right? And then you draw your box and just pick initials. I've thrown my initials on this document, right? But that's it. There's no active digital signature behind it. So it's that easy if you just want to quickly add initials to a page. You can also set this up where if it's a long multi-page document, you can tell cosign in advance, put my initials on every page. You don't have to go page by page and add them like I just did. Does that make sense?
Yeah, it sounds great. I mean, you can get that from the team, I guess, and roll it up and get an electronic official signature, digital signature at the end. So I think, oh, wait, we still have a few more minutes, so let me grab a few more of these questions that have just come in. How do you handle batch processing? So we have a batch utility. You install it either on a desktop or a server. You drop your documents into an input queue. The batch utility picks them up, applies the signature that you've designated to those documents, drops them into an output directory. So and it just sits there and runs in the background, and it'll run 27 by 24. You drop things into the input directory. They get signed and dropped in an output directory automatically by this utility. Okay, and one more question. Is one advantage of cosign being able to use a consistent interface between applications versus having to learn how to use each one's internet UI? Yeah, so if you saw my demos here, I mean, it's consistent under those applications. So you really get to sign in a lot of different ways if you want. But for example, with Word, you're going to get the Word interface. Okay. With Adobe, or I'm sorry, PDF, you're going to get something that looks very similar to PDF. So it's kind of context specific, right? If that makes sense, because the signature has to be applied in a way that the native application understands it. But this is also useful for the users. I mean, if the user is used to using Acrobat or Word or Excel or Autodesk or Lotus, they're going to get a UI that they're familiar with. The signature part of it is going to look like a natural component of the application that they've been using and like to use, right? Does that make sense? It does. It does to me, but I'm just monitoring that through the people who are typing as fast as they can. Is there a summary report that lets you know if all files processed via batch routine were signed successfully?
That's a question for one of my sales engineers. We will need to get back to them on that. But I would suspect there is a way to tell if anything failed. In other words, my guess is if it fails, it stays in the input directory. It won't get transferred to the output directory.
Okay, what happens if I want to use digital signature with an application that was not on your list? Can you guys configure it to make it work?
Yeah. So the beauty of cosign is you got a couple ways to do that. You've got what we call a virtual signing feature. So any content or application type that's printable. For example, here's Notepad represented. I can sign that Notepad document, but the output in this case will always be a signed PDF. And then we also have an API. So if you're not working in any of these specific content types, or your content type is not printable, or if you don't want to have a PDF as your output format, we have an API that can be applied to that specific content type and get the signature on something other than one of these. But you could tell we have a pretty broad support, probably better than anybody as far as the diversity of content types we support. All
right. Well, thank you so much. We're at the end of our hour. I've been responding to as many folks as I could, telling them that yes, we will have a copy of the presentation available on our fiatech.org website. And John, you will probably want to just look through the list too, because there's a lot of folks that would like more information and follow-ups and copies of the slides if you're willing to give those out, so that they can share with other people in their companies. A lot of interest here. I want to thank everyone, those that participated, and certainly John and her friends at ARX for spending the hour and sharing this with us. Hope everyone has a great remainder of the week, and we'll talk to you next week. Thank you.
Okay, thanks everyone. Bye-bye.